Good afternoon, everyone, and welcome to Big Data London, to our Dell Technologies and NVIDIA session around innovating with biomedical research. So without further ado, we'll just do some introductions first. So I'll introduce myself and hand over to Robert. So Tariq Hussain, I run our Dell Technologies public sector business, and I'm glad that we're joined with Robert. If you don't mind introducing yourself and just a little bit about what you do.
Hi, so I'm Robert Esnouf. I run a platform that we call the Biomedical Research Computing Platform in the University of Oxford, and it's the largest platform supporting probably the majority of the biomedical research that Oxford's doing. So it started quite a long time. I've been doing this for a long time. It really kicked off when next generation sequencing came in and universities could afford that. It was about 2007. And so the geneticists just had too much data to hold with. And so somebody gave me a job and said, I was a structural biologist before, if that matches with any other people. They gave me a job and said, well, try to organize the geneticists, but don't let them use my private cluster. So buy a cluster and sell bits of it to people. And it was always, from the beginning, the whole idea was to sell, and not sell ours, but sell like a percentage of the cluster. So if 5 groups own the cluster, they could all buy 20% of it, and they just piled in. And so that started. By 2017, the university opened the Big Data Institute, which you may have seen there, and rather than set up a rival facility, they were very happy for me to grow the facility, spread across the 2 buildings, change the remit, move a bit away from genetics to these large health data sets that are looking at the causes, consequences, treatments and cures for common diseases, particularly common diseases. Another word for common diseases is complicated diseases, I have to say. So that gave a focus. We've always supported large biobanking problems, so UK Biobank in particular, a lot of their base processing has been done with us over the years. One thing I think BMRC has succeeded as is it's always been a place where researchers can come to collaborate, and I think that's a very important role for computing. Separate from having the buildings, everybody can come and work on the piece of data. If you've got a great bit of clinical data and you want a mathematician to invent a new method of statistics, brilliant. We'll set you up, we'll control all the access, we know how to do all that. A lot of what we're doing these days, the balance has changed, but there's an awful lot of, Oxford's an experimental university. A lot of biomedical data these days is imaging data, potentially even videos. Processing that is the dominant thing that we have to do. It comes off at a high rate. The processing has to be very close. And you're talking, GPUs are doing a lot of image processing. Yep. So that's cryo-electron microscopy, digital pathology, functional MRI, those sorts of large data sets.
Yes. No, Robert, listen, look, and I feel like we've jumped straight into the deep end. So I think just for the benefit, I know, and some of the audience will know, but just for the benefit of the audience, what it is that your platform does, and how you're using that to innovate and obviously drive biomedical at Oxford. You give us just a little bit of an overview around that.
So what it does, so it's evolving rapidly. Computing never stays still. Nobody ever thinks they've cracked their problems. We're evolving from, we start off with a traditional cluster with high-performance storage, something that every university would recognize. Hopefully during this year, and with a lot of help from Dell, we're going to complete the transition to be private cloud first, across everything. We still have high-performance storage. Our users are familiar with it. We have to remember that our users are not necessarily computer professionals, and they shouldn't be. We shouldn't put that barrier to stop the cleverest lab people, clinicians, very often clinicians, coming in and looking at those data. So we have to make access easy, we have to keep it familiar. So what happens when you're thinking of this experimental research? You often have periods where nothing's happening, they're going away and thinking, they're collecting data, and they come back with these data sets, and then they suddenly want a burst. And so lots of these groups all want bursts of well-managed compute, and this is a perfect selling model. Hopefully there are enough groups, probably 250 at the moment, and they all fit in randomly around each other, and most things work. Again, as I mentioned before, bringing in collaboration, mathematicians, statisticians. We've got some of the most eminent statisticians around. They actually want to come and work on the most interesting data. So we can enable that. We have those platforms, and indeed AI professionals want to come and apply AI methods to large, good quality data sets. And so in a sense, we're breaking down those boundaries. Research is now much more interdisciplinary than ever it was. So we're breaking down those bricks and mortar boundaries of the ideas of individual departments. Everybody can come and play.
So you're seeing those silos really break down?
Really, really. So at the end of, towards the end of the pandemic, there was a study which was done on our platform looking at basically the blood markers that show how COVID is progressing, what sort of treatments you're likely to end up. Is this going to become that you're in an iron lung, or do you just need a pill and you go home? If you could get those markers early. So that was a collaboration with lots of sensitive data sets, lots of multi-omics data, 200 researchers across 20 departments in Oxford, all with segregated access to the right bits of data coming together. So that, I think, is the largest we've done today, but I think the university has seen that as an exemplar of the future, bringing the right people all together on a place where they can play. And I think one of the great things about computer platforms is there aren't second-class citizens there. We're essentially a remote platform, but anybody, anywhere. I was thinking of an example around biobanking. You get quite a lot of sort of surveys and textual-based material. Well, why not have a linguistics person from the linguistics department come in and use it? And we can do that, and the fact that they're in a small department and have a little PC makes no difference. They can look. And I suspect there are some very interesting things about how people respond to health surveys, depending on their socioeconomic background. We do now support groups from sociology and other parts of the social sciences. These are, becoming very important places going forwards. And the data is every bit as sensitive, every bit as large, every bit as difficult to work with as biomedical data.
Yeah. No, look, I think that's really an important thing, and we're seeing that not just in research, but across UK public sector around that siloed approach. And again, we have some great elements of excellence in those silos, but about bringing it together. Now, you mentioned earlier, just as you were talking then around high performance compute and looking at those data platforms that are being scalable. How are you using HPC and those data scalable platforms to, I guess, drive better collaboration, kind of touched on silos, and again, new scientific research? How are you using that?
How are we using it? So, at the moment, we are primarily file system-based, fast access. That is one of that familiarity is a big advantage when people are specialized. If you are going to use public cloud, that storage is going to be very tiered, very siloed. You're going to be pulling back, getting it onto block storage, getting it onto tier. You have to actually manage that. You have to do that work. People don't want to spend the time doing all that. They do just want to come to us. Another reason they come to us is because probably 3/4 of the data that we're holding would count as sensitive in some way. We don't take the very, very highest levels, but whole genome sequencing gets fairly high up the security tree. And we have, we understand the processes around getting all that paperwork done. We're very clear that data have to have an owner, and it has to be a person. It can't be an organization, can't be the formal owner of data. And so that owner, who is usually the principal investigator, has to be able to get through the processes, has to be able to report, and we can help them do that. And people will come to us purely because we know how to get that done in the university context. And I think it's been a big battle again since the pandemic is to improve the way the university deals with governance, to get accepted as an everyday job. If you have to go through the full data protection impact assessment, that could before the pandemic have taken a year, 18 months to get somebody to consider it from a legal perspective. We are now getting to see some of those more sensitive cases. We're turning around those answers in maybe 8 weeks. It's not quick, but it's doable. Yeah. And if you think, most people only come to us when they've got the money and they want to get started. Yeah. To say, now wait 18 months. Yeah. You can't do it. So actually these processes, some people literally just come. Another thing I think we do very well, and it's largely thanks to the links of UK Biobank, is if we have these large curated data sets, we'll share them around Oxford. So provided you've done all the paperwork with a UK Biobank project, Yeah, you can just use the one central copy. This is so much greener. It's so much quicker. I mean, it would be an example of an impact, but those who are still using the UK Biobank genotyping data set, that was actually done on our platforms. And we've held it ever since. Most of the functional MRI data for UK Biobank are still on our platforms, and if you want to do imaging studies, it's just there. You can just pay to access it. Happily, UK Biobank understands that the public cloud is not well suited to large imaging studies. And so there is a process becoming of exceptions, but we will manage that for the researchers and make sure it's all done.
Yeah, and that brings me nicely on to, you mentioned it there, some of the challenges that you faced, right? And I think they're not alone, and many people in this audience will face those challenges as well at some point or another. But challenges around infrastructure, clearly you don't have any with Dell. But joking aside, there are plenty of other challenges around, I guess, agility, compliance, security. You touched on it a little bit there. How are you addressing those challenges and making it easier for your customers?
So almost every discussion that I get involved with in the Central University at the moment actually begins with the question of who owns the data. Yeah. You cannot really plan, you cannot build your structure until you have decided that, until you have the lines of responsibility. You have to have access to information governance professionals, and I think probably within the year, every medical science department in the university will have a definite access to an official IG person to give initial assessments. This is a complete change. So these things are not a problem anymore. We keep lots of paperwork in the background for everybody. So people come to us because, I always say when I'm introducing a new group, there are the university's rules and regulations that you have to follow, and I suspect everybody here has to follow something very similar. If you can go and do it on your own computing, you have to do all that yourself. Do you know how to do that? Will you be patching every machine every 30 days? Come to us. You can't not do it. You have to pay, but we are doing all this for you. And to streamline that, the university is really changing about how it does that and how it thinks about financing research. And I suspect those of you here who are in higher education, how are you going to finance the research computing going forwards is a constant worry. The kit, the individual chunks of kits, thank you Dell, are getting so, well, NVIDIA mainly, I'll be honest. Dell kit is good value for money.
Still selling, Robert, still selling, brilliant.
Thank you. You have to buy this centrally now, and then you have to think, how are you going to afford that? How are you going to recover the costs of running, the replacement, the governance that has to wrap around it? Yeah, the challenges are not going away. I think coalescing facilities is absolutely essential now. Nobody can afford to do it on their own.
Yes, and I listen, I know you're kind of slightly tongue-in-cheek, but I mean, we've worked with you now for a number of years, right? For a number of years. How's that partnership evolved? And again, not only with Dell Tech, but with NVIDIA. How do you see that partnership evolving over that period of time? And what do you think a good partnership looks like?
Yeah, well, Dell has long been one of my preferred partners. In the structure of the financial structure of the university, we are not allowed to have an exclusive partner, and equally that keeps you guys honest. I mean, there won't. But we really have moved away from the white box providers. It's very important things like having trusted platform module in there, trusted root of security, getting the firmware and driver updates quickly done all the time. We really like the Dell doesn't rebadge firmware, so you can actually just go down to the if they're NVIDIA adapters, we can get an NVIDIA adapter driver update and apply it on Dell kit. You can't on all the manufacturers. I have always liked the Dell is at the level I'm comfortable with. This sounds bad, but it's not over-engineered. Yes. It's not overly sophisticated. The management is not overly tight. You do get the feeling with some vendors that they're trying to trap you into their ecosystem. And okay, the first one will be expensive, but then the future or changing the support is going to sting you. And again, those of you I suspect here from higher education, the universities will claim to be poor. They can usually get capital, but they can't get OPEX. because that's not how money arrives in universities. So you can pay up front, but if they, we cannot get tied into something for multi-year commitments. And we'll all say, this is it, this is up front, give us support. And the other line, which we've always found very strong from Dell, is the technical pre-sale support. And give a shout out. I don't think actually one of our regular ones is here today, but one of the things that I really do like is that when they don't know, they're confident enough to say they don't know, and they will go away and find out. We will ask very difficult questions. I have a very technical team. What is perhaps unusual, lots of university facilities will have managers on the top of them. We don't. Yeah. Even yesterday I was in the server room moving things around and trying to check stuff off serial numbers and part numbers, because it's just what I do. I'm a techie at heart. So we ask really hard questions.
Good.
I have some answers, and they almost always come back. We are looking at new plans and within the time frame for delivering a dedicated AI platform, a whole bunch of really detailed information. Do feel that they care, but they don't feel like we're going to be trapped. So I'm very happy with Dell.
Good. Well, that's a relief, given we're at the stage. But no, thank you. You've done a brilliant sales job. Come and join my team. So moving on.
I may need to.
Absolutely, Robert. So listen, look, I think moving on around how you manage some of that infrastructure and how you provide a service to obviously your customers, which are wide-ranging. Are there any real-life examples that you've managed to promote in terms of actually, again, publishing a scientific study that's been fast-tracked through some of the systems you run? Do you have any examples that you can share with the audience?
I have a few. I've been doing this for a very long time. And so one of the things, this is sort of a bit of a wider point, research is always difficult. It's always changing. It always goes wrong. This is not like business commodity computing when you have a workflow you're just making out. It always goes wrong. It's an old joke that if it worked first time, research would be called search. You just have to do it again and again and again and again. It's a big problem for researchers. For example, if they bought hours credits on public cloud and the first pass goes wrong, what are they going to do?
Yeah.
Their research is screwed. We will help them. We won't tie them to those hours. We are concerned about the research outputs. One thing that the guy who got me started said, getting the money off the people now doesn't matter. You've already got it. You're not going to give it back. Yeah. What you need to do is get them their papers out so they can go to the next grant, get the money, and they will give you more money in the future. But never forget that. It was very clear about how these things should work. And also, and particularly in a high-profile research university, once something works, you're never going to do it again. It's old hat by then. You've got to be there. You've got to get there first, whatever it takes, and then you never do it ever again. So optimizing, worrying too much, get experience, make your best guesses. I think one thing I wish universities did is they trusted their researchers more. They are incredibly clever people. If you can give them a reasonably good platform that's stable and well managed, and say, and this is how you might get the most out of it, they will come with very good answers. So trust them. Yeah. You don't have to be perfect. You don't have to do their thinking for them. But I did think of a few examples.
Please.
And although we don't do as much as it is like, but it's when you get involved with a particular project, you go into the details of why it's not going very well and you make it happen. So I did mention that the genotyping study for UK Biobank was done on one of our clusters.
Yes.
And they did, about 2015, they did a trial run with 100,000 individuals. And that really kills our cluster for nearly 3 months. And everything struggled. And it was a GPFS backend with SSDs and spinning disks. And it really was painful. But then my guy spent a month with the guy who actually invented the imputation statistics, not just the program, he invented the statistics that had to run. And between them, they came up with a new version of the impute algorithm. And it sat there humming at 97+% CPU optimization. The GPFS loved it because it was we understood all the I/O, and it finished in about 2.5 weeks with 500,000 individuals. But that was such an important research output for the University of Oxford that literally my bosses wrote, said, sorry, you can't use this platform anymore. It matters more that we get this result out. And it's very satisfying to do that, and I suspect those who are involved with life sciences, the chances are you have been using that data set, and to be involved with doing is very interesting. Another one where actually we have particular thanks to Dell for helping us up, linked to Biobank was functional MRI. And there are different processings. This is a part GPU application, part CPU application. And because it's in a medical context, you have to have approved pipelines to run, so you can't easily change the software. And they had one problem, and they were doing their pilot studies, and it was in another university. And they're doing pilot studies, and then they started to scale up, and the processing slowed down when they scaled up.
Yeah.
And they came to us, and they said, well, can you help this work? And I said, don't know, but we looked into it. And Dell were fantastically helpful. So it's all to do with PCIe switches inside.
Yes.
And essentially those were saturating. So if you bought the cheaper switches, the cheaper servers where the GPUs were individually connected into the separate CPUs, we got all the performance back and it started to scale again. But that worked, Dell, incredibly helpful. So when it says configuration M, configuration K, whatever, worrying about how the risers work, it all makes a huge difference. That study would not have been possible without Dell people coming back and explaining how it all works. And indeed, I think we may have cancelled orders and put simpler orders in, which were cheaper as well, where all the GPUs were spread properly across the CPU. So thank you very much then. And another one, slightly different flavor, very recently, there's a particular application for processing bioelectron microscopy data, and usually for an HPC platform, we have an electron microscope. In fact, we have 3, which we have to help people use and get research out of. And there's a particular very friendly web-based application that does that. But it's written for workstation. It's not secure. It opens up the data to everybody. So people were unable to say, well, I'm going to take, with electron microscopy, maybe not personally identifiable information, but certainly intellectual property. So vaccine design is actually a new one, literally just come up now. Can we collaborate with a pharmaceutical company, design a new, it's an animal vaccine, and can we keep those data separate and prove we delete them afterwards so that we can do it? Well, we re-engineered a cloud platform. In fact, again, it's Dell backend, the Quad L40S boxes running this platform. And this ties to the governance, and we realized that what matters is each project, not each user. And so every project gets its own master controller, its own web interface, but then using Slurm on the back, and we can do this now. So we can actually do stuff that will develop a new vaccine, which hopefully will be going into animals, in not too distant. So very 2 cases where there's Dell help, but those things are really satisfying and to make stuff work against the odds.
No, listen, I mean, fascinating, and I know we're only touching on the surface around mRNA and vaccines, some fascinating outcomes. I guess switching gears as we're getting closer to the end of the session, but lots of announcements last week. It felt like it was a constant barrage from the world of AI, and I promised I probably wouldn't mention it, but I'm going to. So I'm not going to ask for your thoughts and put you on the spot, but I think it's an incredibly exciting time for the UK when you peel back some of the detail. But actually, what about yourself and someone that is ingrained in this environment? What does the future hold? What's exciting for you? What do you wake up at night and going, actually, I'm excited about what's coming?
It probably sounds very boring for a techie person, but what I'm actually excited about is how the university is waking up and reinventing itself to actually deal with these problems properly, because it is just going to allow us to do things that we cannot do now, to have those processes in place. Now, I know that's not a tech one. I am we're very excited to see what AI can actually deliver to medical research. And it's probably a bit of an AI meeting, but actually the contribution of AI to medical research is pretty modest at the moment. Most of our GPUs are doing image processing, feature detection. Very important job, absolutely.
Why do you think that is, though, at the moment? Why is it only modest at the moment?
I think one of the problems is AI is very good at making a prediction for you, but it's very bad at telling you why it's made that prediction.
Okay.
And, it's like and he gets it wrong, and somehow at the moment, particularly with the hype, people accept AI gets it wrong. That's part of it. It's done amazingly, but it's still got it wrong. But you don't want to go to a doctor and say, yeah, well, that was a really good diagnosis, but unfortunately that's not what I've got. Yeah. It's not acceptable. Getting that insight into how biology works, and it's insight. And I know there are people working very hard, particularly on the infant side, and this is the idea, I think, behind some of these agentic type approaches, is actually to deliver the insight rather than the predictions. And that's the way to go. If we can deliver it, AI is absolutely going to revolutionize everything. The data sets are only getting bigger. That's where we need to be. You have to store a lot of data. It has to be quality data. I would give a warning, again, going back to the pandemic, because you couldn't go back and do a well-designed experiment with controls and whatever. People tried to put lots of bits of data together and do what they call meta-analyses and presented those as being definitive. Almost all of those gave the wrong answer. Some of the false news stories about different drugs work, and you could say, here's a scientific study that proved it. It didn't. What it proved was you combine data where the controls were held differently, when people thought differently. The real quality, and I sound like I'm parroting UK Biobank. It's not the only biobank that uses us. There's the China Kadoorie Biobank and the Mexico City prospective study, all very large studies who work with us. When you have large quality data, you get to see what the real truth is. And that's what those studies are. You're going to need AI to process these volumes of data. It is going to be very exciting. Yes. It's just not quite yet, I have to say. Yes. And it's going to be quite scary to host it all.
Yeah, and you're right. And I think the data element sometimes gets overlooked for those that aren't in your field. Do you think we're doing enough within public sector to harmonize some of that data? Is there enough work and focus? Is there a realization that only AI is going to help once we've got those data sets in a good enough shape?
I think biobank projects have, and I can only speak for medical sciences here. I mean, that's my life for the last 20 odd years. Biobanking has shown that the results are totally different if you do the job right. And so I think there is a lot of understanding that this has to be done. In 2018, the idea that you would sequence 500,000 people for UK Biobank is pie in the sky. That costs £500 million just to sequence all the people. And then to curate those data, to do all the error checking, because you have to do it with the most efficient methods. So I think there's a lot of understanding it has to happen. I think that's the natural way it will go. I think be very wary when people are pulling data in from different sources. Traditional science is a really solid method. Some of the stuff on top you've got to be very, very careful about. But if you can apply the new methods to real quality data, again, an old computer person, there's a saying, whatever, garbage in, garbage out. And that is true. It's never going away from there. We have to make that storage quick, accessible enough. It's one of the things that I think universities, things are coming back on premise. I think that's a common thing because persistent storage in public cloud that you can access and high-end infrastructure like GPUs, those are probably the two most expensive bits of public cloud.
Yes.
And those are the bits where you need to do the governance as well, most clearly. So this is coming back in. I do feel this is quite a strong trend.
Yeah.
Well-managed, consolidated, but not one gigantic system. I do believe distributed systems are the way forwards. Yeah. The way medical data are collected is very distributed systems. We should reflect how the work is done.
And I listen, I think that's an incredible point to end on around that distributed network. There's no one solution. I think we have to work a lot more collaboratively. So listen, look, we are up on time, would you believe it? So we don't have time for Q&A, but please do, if you're around at the end of the session, you want to talk to us, please do. But actually, nicely put, we're going to be hosting our Dell Technologies Forum on the 18th of November. In London, so again, you can scan that and feel free to register where we can continue that conversation more. But just for me to say thank you to Dr. Robert Esnouf, absolutely incredible to talk to you and hear your thoughts. So thanks again, and a round of applause for Dr. Robert Esnouf.
Thank you.